test for the acid radicals. Now, which acid radicals do you have? Do you know? Name some acid radicals in your practical. Okay, carbonate. Now, carbonate. Now, what is the test for carbonate? If you use the weak acid, then it will evolve carbon dioxide gas. This practical you have also seen on the last year, that is on class 10. Next one for sulphide, S2 minus. Okay, sulphide is there, sulphide, SO3 2 minus. Okay, sulphate is also there, SO4 2 minus. So, containing sulfur, this is sulphide, this is sulphite, PHIT, and this is sulphate. Containing nitrogen, NO2 minus, that is nitrite, and NO3 minus, nitrite and nitrate. Okay, and except these, also having acetate, CH3 COO minus. Okay, and the halides also. Now, halides, that is chloride, bromide, and iodide. So, out of these, the very important is the sulphate, nitrate, and halides, basically chlorides. Now, how to test these radicals? Now, these radicals can be tested by two manners. There are two kinds of experiment. One is dry test. What we will do in the dry test? The dry test, in dry test, the dry sample, that is the solid sample, it will be supplied to you. It is in its intact form, will be taken in a test tube. Basically, the test tube will be dry. If the acid we use are strong, that is the concentrated sulfuric acid, we should be aware of that, that if we are using strong acids, then basically the test tube should be dry. So, dry test, that is solid sample plus the appropriate reagent. The appropriate reagents are dilute sulfuric acid, concentrate sulfuric acid, etc. is the reagent. Now, this is the under dry test. Now, as the dry test is having the issuing some gases or just taking the smell of something. So, as you are not present here, virtually you are present. So, this is not possible because you cannot see the effervescence. You can see the effervescence, but you cannot take the smell of that. So, with this respect, we will show you only the experiment which having some changes in the color or any precipitates come in this respect. Okay. So, with this respect, I will show you first one carbonate sample. Now, carbonate sample, when it is tested with dilute acid, an effervescence will occur, and this can be further confirmed by the use of passing the gas through the fresh lime water. Okay. This will produce a layer of calcium carbonate which is insoluble in water. So, the lime water becomes milky. This is the test, you already studied about it. Okay. Now, look at this, the carbonate sample. Okay. So, look at the sample. Now, you will follow the test tube. Clear, everyone? Okay. Now, just give me 1 minute. Okay, so first test is for carbonate. solid sample, taking the solid sample, okay. The solid sample, you have to know the texture, that is it is crystalline solid, okay, and if it is dust form, then you will write it in the nature, that is amorphous, okay. Now crystalline and amorphous, these are the two kinds of crystal. Now look at that test tube, any kinds of effervescence is coming or not. A solid sample is taken and the test tube is also dry. Now I am adding acid, dilute acid, okay. Just look at this, and high effervescence occurred, okay. And a pungent smell is coming out, that is due to the formation of carbon dioxide here. This is one test, this is for carbonate. Now this is the simple reaction, that is CaCO3, we have taken here Na2CO3. So Na2CO3 plus I have taken acid as sulfuric acid. So Na2SO4 plus CO2 plus dilute H2SO4, Na2SO4, sodium sulfate plus CO2 plus H2O. This CO2 is coming out in the form of effervescence. Next one is the test for sulphide, okay. Now sulphide giving a rotten egg smell with the dilute acid, okay, but as the rotten egg smell you cannot take, so I will go for one wet test. Now this is another kind of test, that is wet test. This is done, this is dry test, this is wet test. Now for wet test, what we have to do, first to make the solution. So preparation of original solution or OS, Now how to prepare it? So take a little sample and add 5 ml of water. Now a test tube, this is basically 20 ml test tube, roughly it is 20 ml. So 5 ml, that is 1/4 of the test tube, that is water or distilled water, plus shake it well so that it completely dissolve. Basically the sample used up to class 12 is water soluble sample is given, but out of water they are having in the solubility list, they are having first of all water, then warm water, that is in warm condition, okay, then dilute HCl, dilute, then concentrate HCl, then aqua regia, okay. So these are the list of solubilities, that is the solutions used, the solvent used: water, warm water, dilute HCl in cold condition and hot condition, concentrate HCl in the cold condition, then aqua regia. And if any sample is insoluble after aqua regia, then it is treated as insoluble. They are having a different treatment for insoluble sample, this having individual treatment, and there the physical appearance of the sample is very important. And if any, we have to depend on any dry test. Suppose calcium fluoride is an insoluble sample, okay, so this type of sample should be treated differently, that is calcium will go for the flame test and fluoride this should be fused, okay. So this is different, this is not included in your syllabus. So these are the list of solubilities: water, dilute HCl, concentrate HCl, aqua regia, insoluble, but your limit is only up to water, that is the first one, okay. So preparation of OS, that is sample plus water, shake. Okay. Now look at this test tube, that any residue is left after the solvation, that is after the preparation of solution. So if no residue is there, then it is totally soluble. Now this is kept reserved for the next test, and the solution is taken for the next test is called as wet test. So as in the solvated state, when the test will be done is called as wet test. Now for this, preparation of solution is required. Now the next test is for sulphide, S2 minus. So we have to take one sulphide sample, then we have to dissolve it in the solvent, appropriate solvent, and then we have to test with the appropriate reagent. Now the reagents used for the test of the sulphide is, the sulphide sample is here. So I am taking the sulphide sample in a test tube. These are in the pellet form. Okay. Now I will add here water, just like the theoretical part. Around 8 ml of water added. Now shake it well. Shake it till now residue is there at the bottom. I can show you. Okay, you can see that residue is there. Okay, but now there is no residue, is a clear solution. Okay, so this is kept reserved. I am keeping it here in the test tube stand. Now taking this sample, this OS, original solution, very little amount, only 2 to 3 ml is sufficient. Only 2 to 3 ml is sufficient. Only this amount. Now next, what to do with the sample? That is, first of all, add acetic acid and then lead acetate. First add acetic acid and then test with lead acetate. So this is the dilute acetic acid. And then lead acetate should be added here. A black PPT will arise. Now I will show you. Just look at this. A black PPT. Can you see it? A black PPT is formed. This is the conformative test for sulphide. Okay, the black PPT is here. This is the test for sulphide. Now what is the reactions involved in this test? So first of all, I have taken as sample is sodium sulphide, Na2S, it's having Na plus, and sulphide minus. Now, when it is tested with lead acetate, it will produce a PPT of lead sulphide, this having black in color. This PPT is black. So, the PPT form is of lead sulphide and the salt form is sodium acetate, CH3COON. Okay. So, this is the chemical reactions involved in this. So, what we add, first take the salt, original salt, then add water to it, make the original solution, and taking a 2 to 3 ml from this original solution, we will add first acetic acid and then lead acetate, okay, to produce the black PPT. Okay. So, this is the conformative test for sulphide. So, again I am rejecting it. Next test. There is another one test for sulphide. If you add sodium nitroprusside, then it produces a violet or purple color PPT. Okay. So, again there is another test, but we will go for only single test. Nitroprusside, the reactions is that, suppose sodium sulphate is taken as an example and nitroprusside, it is having a complex formula Na2 FeCN5 CN5NO. This is sodium nitroprusside and the formula for the compound is that Na4 FeCN5NO S. Okay. This is within the third bracket. This is the formula of the purple color PPT. Okay. So, Na4 FeCN5 NOS. Okay. Next is that for sulphide and nitrate is also there, nitrite. Okay, now look at this. We will show the test for sulphide. Okay. So, again the sample will be taken and then to test with barium chloride solution. Now, what is the reactions involved? That is, suppose barium chloride is the sample, then suppose next one for sulphide SO3 2 minus. So, barium chloride solution plus, if the sample is taken as sodium sulphide Na2SO3, then it will produce a PPT of barium sulphide BaSO3 plus twice of NaCl, this one having white PPT. Now, look at this. Look at this, the sulphide sample. So, in the same way, we will produce the solution for this. So, taking a test tube we will go for wet test. So the sample is taken. Okay. Next, addition of water to the sample. Water added. Now shake it well. Shake it well. Now the solutions become clear. Okay, you can see that the solution is clear, no residue left. Okay, now taking 2 to 3 ml from this solution, original solution, we will test for sulphide, that is addition of barium chloride to that solution. Now I will add barium chloride here. Now look at this. So barium chloride, you will look at the bottom of the test tube. What color of PPT formed? What is the color of the PPT formed? What is the color of the PPT formed? White. Okay. Now how to confirm that it is for sulphide? How to confirm it is for sulphide? Now there is a further test, that if we add any dilute acid, that is HCl, then again it will produce H2SO3 plus barium chloride. Okay. So barium chloride, so this is barium chloride. You can see that this is the solution of barium chloride, it is transparent. Okay. So we will add here any dilute acid. Now I am adding here dilute HCl. You will look at that experiment. If the PPT becomes excessive, then just look at this. Just by one drop the PPT dissolved. If we add one further drop, then it becomes a transparent solution again. So this proves that it is for sulphide. Okay. The haziness is there. If we add further more acids, then it will be disappear. Okay. So this is the test for sulphide. Okay. So today the test for carbonates, sulphide and for sulphide are done, that is CO3 2 minus, S2 minus and SO3 2 minus. Now SO3 2 minus can be proved by another method, that is by using potassium dichromate, but it will be seen later on. Now your attendants who are present, Bhavya Saukarya Srijata Sarkar, Shubhojit De. Wait.